Howdy, my name is Forrest, and I really care about performance in SQL Server, which means I really care about things that hurt performance. Today I want to talk about an anti-pattern called optional parameters. It's called a lot of other things as well, but effectively what it is, you see a special construction in the where section of a query that allows for a parameter to exist or not exist at all. There's a null checking going on. And I have seen queries take thousands of times longer with this anti-pattern. Heck, why don't I show you? Okay, I'm going to be working in the Stack Overflow 2013 database, and I'm going to be working with the votes table. This is what it looks like. The key thing I want to point out is that ID is the primary key for this table. So if I have a query and I'm filtering on a specific ID, ta-da, very fast, it's using a seek. Now, there's this clever trick I can do with my query. I can add this extra parameter here. I'm calling it count everything. And what's going on is I add this or to the where clause, and I say, oh, if this count everything parameter is 1, then just give me everything. Now, I'm also doing count because I don't want to actually return all of the millions of rows. I'm just going to count the millions of rows. Okay, so let's run this. Notice that count everything is 1, so it should count everything, and it does. It takes a bit longer. It's counting 53 million rows, and we can see that it does a full table scan. In fact, it goes parallel with this scan because SQL Server sees that it has a lot of work to do. Okay, now what happens if I run that same query again, but I have count everything set to off effectively? This should only return 1 row. What's going to happen? Okay. And yes, it returns 1 row, but notice this still took a little while. In fact, it took 3.5 seconds and scanned the entire table again. What's going on? Well, because SQL Server wants to be able to reuse queries when possible, it saves query plans for the queries it gets. And when it's saving a query plan for this, it doesn't know if count everything is going to be 0 or 1. And so it saves the only plan that has a possibility of satisfying both. The seek plan really could not work for the count everything equals 1 case. Now, optional parameters are actually doing the same thing as this clever count everything parameter that actually ruins performance. And an optional parameter can absolutely ruin performance of a query. So notice here, I have or ID is null. That's the common optional parameter construction because if you don't pass a value to a parameter and you don't set a default, that parameter is going to have a value of null. So let's try it with this. Even though ID is not null, right, it has a value, running this query takes 3.5 seconds. Now, I want to point out that doing it the normal way here, that's 1 millisecond. The difference between 1 millisecond and 3.5 seconds, that's a thousands of times difference. Big difference. What can you do to fix this though? I say there are 3 main solutions to this. You can fork your queries. You can say, oh, if we have the parameter, do this. If we don't have the parameter, do that. You can use dynamic SQL, or you can use option recompile at the end of the statement. Now, each of these solutions has strengths and drawbacks. Overall, I'd probably say the best solution long-term is dynamic SQL. And they're kind of gotchas with the other two. Okay, so let's start again. Remember where we're at. We have this query here. We have the optional parameter anti-pattern, and it takes 3.5 seconds. Ugh. And notice that's 3.5 seconds of clock time on my laptop. The actual CPU time it's taking up, that's 4.5 seconds of CPU. Ugh. All right, so here's what I mean by forking. I have if ID is null, and then run this query, that's a full scan, and then an else, run this. Well, let's try it. Here it is with a null. It's going to count everything from the table, so it's going to take a while. All right, yeah, it took a while. 3.5 seconds, not a surprise. What happens if I add in the number? And it's fast. It's really fast. It's 3 milliseconds fast. Big improvement. Drawbacks with forking. You can get weird parameter sniffing issues, but if your queries are simple, who cares? Also, with forking, it really only works if you're only dealing with 1, maybe 2 of these optional parameters. Because remember, you have to create a fork for each parameter. And so with, it basically doubles every time. If you have 2 parameters that are optional, you actually need to make 4 possible queries. 3, and you end up with 8. It can get messy fast. The best long-term solution is going to be dynamic SQL. It doesn't matter how many parameters here are optional. You just add in the correct conditions. Here's the simple form with just a single parameter. Although now that I'm looking at this, let me say the common form with dynamic SQL is to have a where 1 equals 1 here, and every single possible extra where condition is just an and. So there's no complicated, oh, this one's first, let me put a where there. Nah, it works out better this way. Okay, so with dynamic SQL, make sure to use sp execute SQL. It takes in a SQL statement, it takes in parameters, and then it takes in your actual parameters at the end. So let's show how it works, which is, it works well. Again, 3 milliseconds. Now, with dynamic SQL, yes, it can be a bit annoying to write, but that's pretty much the only downside. Yes, it's an annoying downside. Performance-wise, great. Edge cases, great. Is there a particular parameter that you always want to add a query hint with? You can do that too. Very flexible. I love it. The final option I want to talk about is adding in this option recompile. Now, I would say this is probably my least favorite option. Part of that is just I'm a little bit biased. So I'm a DBA, and I like being able to find and see information about bad queries in the plan cache. But what option recompile does is it tells SQL Server not to keep that plan in the plan cache. So if you put this on a query, I can't see any information about it in some of the most common DMVs. It hides a lot of really useful metrics. On top of that, it causes the plan to be compiled every single time it's run. In some environments, that's not a good thing. For some queries, that's really not a good thing. But it can work, and let me show you. So here I have the parameter, I'm giving it a value. Here I have the exact same query with that or is null. All I do, add in option recompile, and boom, it works. Super fast, too fast to measure right here. If you want to get a sense of whether option recompile is safe for you, here's what you can do. You can go to the query and you can look at the properties, and up here you can see compile CPU. That's going to be in milliseconds. In this case, it's too fast to measure. And you can probably get a sense of whether or not this is a good idea by looking at how much CPU it takes up to compile and how often that query is going to be run. If you're dealing with a query that's being called tens of thousands of times a second, and yes, I've seen queries like those, you probably don't want to be compiling every single one. And there you have it. You see the danger of the optional parameter, and you have a couple of fixes in your tool belt. Again, please remember, option recompile, super fast, easy to slap on, but it can really bite you later on.